In this video, we're going to introduce a new method for solving quadratic equations. We're going to begin in part A by solving the equation x squared minus 5 equals 0 using the square root property. To solve the equation x squared minus 5 equals 0 using the square root property, we have to begin by first isolating the x squared, so we'll add 5 to both sides of the equation to obtain x squared equals 5. Then this is the point where we apply the square root property, which says if x squared equals 5, then x either equals the square root of 5 or the negative square root of 5. And we have our solution set. The solution set is the set root 5 comma negative root 5. In part B, we are asked to solve the equation 2x squared plus 4x minus 5 equals 0 using the square root property. The problem with this equation is that we have the center term, the 4x term. Because the variable x occurs twice in this equation, once as a squared term and once as what we would call a linear term, an x to the first term, the square root property cannot be applied very easily. So the best answer we can give at this point is, we do not yet know how to do this. It would be incorrect to say that it is not possible to do this. It is possible to do it, but it will be covered in the future. So let's take a step back and answer part C. What is a quadratic equation? The definition we are using for what a quadratic equation is an equation that can be rewritten as ax squared plus bx plus c equal to 0, where a is not equal to 0. A quadratic equation may or may not be in that form, but is one that can be rewritten into that form. This brings us to part D. What is the quadratic formula? The quadratic formula is a formula that can be used to solve any quadratic equation. More specifically, if the equation we are trying to solve is ax squared plus bx plus c equals 0, then the solutions are x equals the opposite of b plus or minus the square root of b squared minus 4ac, all of that over 2a, where the a, the b, and the c reference the a and the b and the c from the quadratic equation that we're solving. This formula can be used to solve any quadratic equation that we could come across. Now in part E, we will return to the equation 2x squared plus 4x minus 5 equals 0. And the first part of part E is to address what are the values of a, b, and c. Remembering that a standard quadratic equation is ax squared plus bx plus c equals 0, our value of a is a coefficient on the x squared term. Our value of b is a coefficient on the x term. And our value of c is the constant. So our values of a, b, and c are a is equal to 2, b is equal to 4, and c is equal to negative 5. It is critical that you recognize the sign in front of a, b, and c gets carried into the value of a, b, and c that we're going to use. So if this had been a minus 4x for the middle term, then our b value would have been a negative 4. Carrying the sign of a, b, and c will completely impact the work we do when working with the formula. In part 2 of this, we need to now solve the equation using the quadratic formula. As a reminder, the quadratic formula for the equation ax squared plus bx plus c equals 0 is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So what we need to do is substitute into that formula the value of a, b, and c that we have identified in part 1. So for us, the quadratic formula will become x equals the opposite of 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 5, all of that over 2 times 2. To simplify this, we need to follow the order of operations, and the first work we need to do will be underneath the radical. Under the radical we have 4 squared, which is 16, and negative 4 times 2 times negative 5 is a positive 40. In the denominator, 2 times 2 is 4. So this will simplify down to -4 plus or minus the square root of 16 plus 40 all over 4. Continuing our work, we need to finish simplifying under the radical. 16 plus 40 will be 56, and so we get -4 plus or minus the square root of 56 all over 4. Anytime we're working with radicals, we do need to simplify them as much as possible. 56 is divisible by 4. 4 times 14 is 56. So I can split that square root of 56 into the square root of 4 times the square root of 14, and our expression becomes -4 plus or minus root 4 times root 14 all over 4. Now the purpose for the work that we just did is the square root of 4 simplifies to 2, giving us -4 plus or minus 2 root 14 over 4. We can simplify this further because both terms up in the numerator have a factor of 2, and there's a factor of 2 in the denominator. So we can cancel out a 2 from each factor in the numerator as well as the denominator. If we were to do this, we end up with x is equal to -2 plus or minus root 14 all over 2. And those are our two solutions to this particular quadratic formula. -2 plus root 14 over 2 and -2 minus root 14 over 2. Since we did solve an equation, we're going to finish off with the solution set notation, but we can keep it in this compact condensed form that the solution set is the set -2 plus or minus root 14 over 2. It is critical that we recognize there are two solutions in this particular equation. If it helps you to see this by writing this as two separate solutions, you are free to do that as well, in which case the solution set would be the set -2 plus root 14 over 2, comma, -2 minus root 14 all over 2.